Welcome to the Slop Temple. We pray this video helps.
You start by identifying independent meshes and assigning mesh currents, typically clockwise to avoid sign confusion. Once done, label every resistor and voltage source with values and polarities so the calculator input matches the schematic. Next, write a KVL around each mesh. Sum voltage drops equals sum rises, including resistances times mesh currents and subtracting shared resistor contributions. This creates the linear equations you'll enter into the solver. Make sure shared elements use relative current differences. Now translate each KVL into standard linear form so the left side contains resistor coefficients times mesh currents and the right side contains mesh voltages. Once you have those coefficients, assemble the coefficient matrix and right-hand side vector. Double-check units and signs because a single sign error breaks the solution. Then enter the matrix and RHS into your calculator's matrix editor or linear solver. Run the solver to obtain numeric mesh currents and inspect the output for obvious magnitude or sign mistakes. With mesh currents solved, compute any branch currents and voltages by combining mesh currents. For a shared resistor, use the difference between the two mesh currents. Once computed, verify by checking power balance or plugging currents back into original KVLs to ensure residuals are near zero. If numbers look wrong, troubleshoot. Recheck sign conventions and KVL directions, confirm each matrix row corresponds to the correct mesh equation, and ensure shared resistor coefficients are entered as negatives where appropriate. Small input mistakes cause big errors.
Thanks for watching. Consider subscribing if we helped you.